Hey guys, previously we took a look at how to add layers to a neural network. Now we're going to look at the various options for adding nonlinearity to a layer in the neural network. Nonlinearity is introduced using activation functions. They're mathematical operations with varying complexities and output ranges. A dense layer, that line of code takes two parameters. First is the number of neurons, while the second is the activation function. In this case, we're making use of the rectified linear unit. There are many activation functions. Some of these are smooth nonlinearities. You could see them on the screen. They could strain the output to a particular range of values. This is commonly called squashing. For example, sigmoid constrains the output to a range between 0 and 1, while hyperbolic tangent constrains it to a range between -1 and 1. Another class of nonlinearities is called a continuous nonlinearity. This type tends to have an edge at some point. It's usually cheaper to compute. For example, the rectified linear unit uses a condition to determine the output. If the input is less than 0, then the output is 0. Otherwise, the output is the same as the input. Let's look at some code to see how to make use of these activation functions and what the computation cost might look like. We got our notebook open, and make sure the TensorFlow is installed. Then import the necessary modules, as well as fashion MNIST. What we have here is a model that makes use of the sigmoid activation function. After training, we could see the various metrics associated with that particular training run. Next model, we could see what the metrics look like when we switch to the hyperbolic tangent. This change might be small at the moment, but it'll be much greater when you deal with larger images and larger data sets. Next video, we'll take a look at optimizers